Hi, my name's Ethan, and together with my teammates, we'll be presenting our project IdentiFly 360. I'm joined today by my teammates Abum, Zach, Armando, and Nika. So first, we're going to go over the background of our project and why it's so important. We'll go over how our project works and give a demonstration of it. We're going to go over the exciting results we've achieved with IdentiFly, where it fits into the market and the market research we've conducted, and finally, we'll go into the future steps for our projects. So over the past 100 years, fruit flies have been crucial for genetic research. They've led to groundbreaking developments in our understanding of the human nervous system. They've led to discoveries of various therapeutic drugs, and most recently have been used in cancer treatment research. Now, one of the most important aspects of maintaining a colony of fruit flies for research is being able to separate them male and female. This allows researchers to control the mating process and ensure validity of breeding experiments. Now, in 1910, when Thomas Morgan, the father of fruit fly research, first began experimenting on flies, he sorted them male and female by hand. Now, if I were to ask you today, with all our technology, how much has the sorting efficiency increased over the years? Well, unfortunately, I'd have to tell you absolutely no progress has been made. Today, 100 years since flies were first used in research, they're still sorted by hand. This is tedious and time consuming. A researcher's time is much better spent investigating new life-saving drugs or running new experiments. What we, the members of IdentiFly, realized is that there must be a better way. Enter IdentiFly 360. This is a low-cost device that provides labs with a convenient and easy way to automatically sort fruit flies by sex. With that said, I now give you IdentiFly 360.
Now that we saw the device in action, we will go over the designs that made IdentiFly 360 possible. We created 3 entirely different designs which each accomplish the same major tasks, and ultimately we settled on the IdentiFly 360 due to the gentleness and consistency of the device compared to the other designs. IdentiFly 360 maintains a central axis of rotation to move a fly over the camera into the bins in a circular motion. Automatic calibration with an ultrasonic sensor on powering of the device and after each fly classification allows for consistent results. Serial communication between the Arduino, which controls mechanical movement, and a Raspberry Pi, which controls both the camera and classification algorithm, supports a modular separation of ideas. The IdentiFly app, which is currently being Bluetooth integrated, will offer an enhanced user experience on top of the existing functionality. The app will allow a researcher to specify sorting criteria, start and stop the device, and track the progress of their sorting in real time. Our streamlined process consists of 4 major steps. First, we sedate the fly in a refrigerator at 4 degrees Celsius so they're immobilized. Then we select an individual fly using the vacuum mechanism. After that, we snap a photo with a camera, and after using a machine learning algorithm, we sort the fly into its correct bin. Now we'll go over each step more in depth. The compact design allows for our device to be used inside of a refrigerator, allowing the flies to be sedated throughout the process. Now Zach will cover the select, snap, and sort stages.
Thanks, Abum. In order to pick up a fly, our device has a vacuum connected to tubing and a nozzle, which is attached to the arm. The vacuum provides controlled suction so that a fly can be carefully picked up without being damaged and dropped in the appropriate bin once it has been classified. In addition, there is a precision nozzle at the end of the tubing to allow one fly to be picked up at a time. Once the fly has been picked up, it will be moved over the high-resolution camera. This camera has LED lights next to it in order to provide enough lighting for a high-quality image inside a refrigerator. Once the arm moves over the camera, our software will detect that a fly is there so that an image can be taken and classified. For a brief background, there are two main factors that can be used to identify flies as male or female. Male flies tend to have smaller bodies and also a black spot on their abdomen. We tried a number of different machine learning algorithms in order to classify the images. We ended up deciding that a decision tree worked best because this gave a 98% test accuracy and 0% false positives, meaning that no male flies were put in the bin with female flies, which is important because we don't want the male flies to mate with a number of the females and cross traits when this is not wanted, and these flies would have to be discarded if that happened. Finally, once the flies have been classified, they are placed in the bins. These bins are easy to remove, and each has a capacity to hold over 1,000 flies. The bins consist of a bin for male flies, female flies, and a third bin for flies that were unable to be determined by the algorithm. The flies that were undetermined can then either be run through the system again or simply discarded if this is not important. I will now pass it off to Nika to talk about our specifications and market research.
Thank you, Zach. We did a market research where we asked what researchers are looking for, and we found 4 distinct features. In order for our device to be differentiated on the market, we aim for the following initial target specifications. IdentiFly 360 was able to meet and exceed those demands. We focused on a small design, so the device would not be a burden to place within any labs. Our design allowed us to place the whole device in a fridge as a method to sedate the flies. This allowed us to considerably cut production costs. To be competitive on the market, it also had to achieve a high performance in terms of speed, around 100 flies per hour, and high accuracy in order to prevent contamination. Let's dive into a deeper market analysis. We target all labs around the world that are working with fruit flies. Our value proposition is the low-cost automatization of the fruit fly sorting process. Initially, we focus on gender separation, but our software updates will allow for any classification based on any traits in the future. Because of low production costs, we are flexible in choosing high margins and still stay within our targeted price range. Our product is at least 4 times cheaper than the best alternative. Our product is also comparable in terms of speed and is the smallest across competitors. I want to mention, however, that none of our competitors have launched their products on the market, so currently getting a sorting fly machine is not an option. Further, we can see how IdentiFly position on the market compared to its competitors in relation to 2 dimensions, low cost and utility. IdentiFly position is the lowest cost and has the highest utility. I'll turn it now to Armando. Thank you.
Thank you, Nika. Now we can go into the cost analysis of IdentiFly. As you can see here, there are 3 major categories of cost, that being laser cut, mechanical, and electrical components. In order to attempt to minimize the cost of IdentiFly, we focus most of our costs on our electrical components in order to maintain high resolution and accurate photos for classification. And to minimize our costs on laser cut and mechanical parts, we use easy to access parts that were readily available. Now going into revenue analysis, we know that there are 3,300 labs using fruit flies in research across the world. Given our market research, we determined that a $750 market price would be reasonable for our market. This leads to a $2.5 million market space, and given our costs, it would lead to 58% profit margin per device. Now, this profit margin is only for the initial sale of our device. As we continue to develop additional classification software updates, such as balancer chromosomes and virginity, as you saw in the demo, we can charge these as add-on packages for our consumers to purchase. Now, looking forward into IdentiFly, there are 3 major components we want to focus on. First, we want to finish the Bluetooth integration between the device and the app. Additionally, we want to develop these classification features that I've mentioned. And finally, put our device out for beta testing and validation through our partner labs in Philadelphia. We are IdentiFly, and we thank you for listening to our presentation. And finally, we'd like to thank all of the BE lab and staff and our mentor, Dr. Catherine von Reinep Drexel, for making this all possible. Thank you again.